What you guys asked about was number 6 on, again, assignment 2, unit 12. And so for number 6, what I wanted you guys to notice is that, yet again, one of the big sticking points is period versus frequency. Which one was it that was provided? And so in this particular case, I wrote out exactly what was on the board, or sorry, on the problem. And what I want you guys to see is that the way the units are laid out, they tell you exactly which one you're dealing with. This is the number of times you see a wave per second. And if it's that number of counts, number of cycles, number of times you see that occurrence per second, this is going to be a frequency. So yet again, frequency was provided to you. Your frequency here is going to be 0.25 hertz. I believe letter A, they ask you for period. You've got two options. When you want to solve for period, the first option is that you can invert this little fraction that you've got here. You could say that period is equal to your 1 second divided by 0.25 waves. 1 divided by that quarter is going to give you 4. Or you could use the equation, the relationship between period and frequency that we used first semester. I'll make that F look more like an F. T is equal to 1 over F is equal to 1 over T. They're inverses of one another. So this could have easily also just been 1 divided by 0.25 here, and that would have given you your 4 seconds for 6A. 6B then asks you what is the wavelength. That one's identical to number 5. So you're going to go back and use that exact same equation of V is equal to lambda F, wavelength multiplied by frequency. You've got a speed that was provided. The frequency was 0.25. Plug those guys in. You should get the same value. Oh, I didn't provide answers on this one because I suck. My bad. So 4 seconds was 6A. And then when I go ahead and actually plug in all the values there for 6B, V is equal to lambda multiplied by F. Our velocity was 16 meters per second. That's equal to wavelength multiplied by 0.25 hertz. Divide both sides by 0.25, you should get yourself a wavelength of 64 meters. And then again, letter C is asking about that inversely proportional relationship between wavelength and frequency. So if your wavelength increases, your frequency should decrease. If your frequency increases, then likewise your wavelength should decrease if your frequency increases. Yeah, that's it.